Working with alignment design checks in Civil 3D. Created by Ahmed Dmour. Welcome to this tutorial on alignment design check in Civil 3D. In this lesson, we will learn how to create, apply, and manage design checks that help ensure our alignment geometry meets project standards. We will cover creating checks for tangents, curves, spirals, and then combine them into a design check set. What are design checks? Design checks are mathematical expressions that evaluate alignment subentities, lines, curves, spirals, and tangent intersection groups and return true or false. They let you verify parameters that aren't in the design criteria file or add project-specific rules. For example, tangent length must be more than or equal 100 meter, or if design speed more than 80 km per hour, then minimum radius more than 300 meter, and spiral length must be more than or equal x for this wheelbase. Design checks differ from label expressions. They don't return text, they only return pass or fail. When check fails, Civil 3D issues a notification for the affected entity so you can correct it. How design check are organized in Civil 3D? Design check a single true or false expression for one entity type. Design check set a collection of design checks like a label set. You assign a set to alignment. Civil 3D evaluates all check in the set for the alignment. Application: a design check set can be applied during alignment creation or later via the alignment's properties. Setting design checks. In Civil 3D, design checks are managed in the Setting tab. Then in Alignment, expanded, then Design checks. Here you will see subcategories for lines, curves, spiral, tangent, and super elevation. Here, creating a new design check. Tangent minimum length. Right-click in lines under design check here. Expand it. Right-click, then choose new. Design check editor dialog opens. Let's create our first design check for minimum tangent length. Give the check a clear name like tangent length greater than or equal to 100. In description, tangent must be greater than or equal to 100. In expression, insert the tangent length property from here. Choose length more than or equal 100. This formula returns true when the tangent length meets the requirement and false when it doesn't. Click OK to save. Tangent length more than 100, this formula appear here in line. Creating a condition design check, tangent length at speed. Right-click in line, then choose new. Name it as tangent length more than or equal 100 at 45 km per hour. Go to formula, then choose if condition. After that, open parentheses, then choose design speed more than or equal 45 km per hour, then close the parentheses, then comma, open parentheses for length, tangent, choose length, then more than or equal 100 meter, close the parentheses, comma, 1. 1 is the value returned if the condition is false. This means the check is ignored for design speed below 45 km per hour. Then close the if statement, then OK. This is the formula, tangent length more than or equal 100 at 45 km/h. Creating a curve radius check. Now, for curves, we often want to validate the minimum radius at different design speeds. Here, we use a nested-if structure. For example, if the design speed is 120 meter, the radius must be at least 750 meter. At 100, it must be 500 meter, and so on. This allows one design check to handle multiple standards. Minimize line, then expand curve, new, name it as curve radius by speed, then an expression. For example, if the design speed 120 meter, the radius must be at least 750 meter. Now go to F, then click in design, design speed more than or equal 120 meter, comma, then choose the radius more than or equal 750 meter, then comma, then enter, then repeat this statement and copy another one and change it the speed to 100 and 500 meter and speed here to 80 and radius 300, finally 60 and radius 120 meter, then enter, then radius more than or equal 0, then close the parentheses 4 times. 1, 2, 3, and 4. 4 parentheses, finally. Then OK. Thus, we have succeeded in including the condition statements for the curve, which we can use later when creating the road and making the check design. Saving a design check set. Once individual checks are created, we combine them into a design check set. In design check set, expand it, then right-click, New, Information, give the set a descriptive name as Urban Roadway Standards. In Design Check tab, add the checks we created from type, line, then in line checked, choose tangent length more than 100, add, and also tangent length at 45 km/h, add, and then in curve, choose curve radius by speed, add, then apply. OK. Now it has been added to the list of the design check sets.